the last lesson in Chapter 4 is all about classifying numbers and really deepening your understanding through sets of numbers and how to create a hierarchy so you can see the relationships between sets of numbers. So we started off by looking at which types of numbers do you know, and really you should know all of these, and some of you knew them better than others, but this is a chance to learn. And I had you write down a few examples of each and look for patterns to describe the set. So the prime numbers is the set of all numbers that have exactly two different factors, and they continue infinitely. Here are a few. Real numbers are all the rational and irrational numbers. So all of the rationals, numbers that can be written as a fraction, and all the irrational numbers. So irrational numbers, decimals that never terminate and never repeat, like the square roots of non-perfect squares. Pi, the golden ratio. We can graph them on a number line. They are real, but they cannot be written as a fraction. That's the big difference. All decimals can be written as fractions. All whole numbers can be written as fractions. If it's a whole number, you just put it over 1. If it's a decimal number, you read it and you write what you hear, with the denominator being a power of 10, 10 or 100 or 1,000, etc. The set of integers is the number line where we've got all the negative, quote, wholes, 0, and all the positive whole numbers. So it's all the whole numbers and their opposites. No fractions, no decimals. The counting numbers are the set of numbers where if I was going to count the number of students in the room, I would start with the number 1, 2, 3, etc. Whole numbers are all the counting numbers and 0. That's the only difference between these two sets of numbers. Whole numbers include the number 0. Even and odd numbers are integers that end in 0, 2, 4, 6, or odd numbers are integers that end in 1, 3, 5, 7. So it can be these numbers and the negatives of them, these numbers and the negatives of them. So they also can be negative. Rational numbers, talked about, any decimal, fraction, mixed number. Any repeating decimal, like 1/3 is 0.3 repeating, so any repeating decimal can be written as a fraction. Negative numbers, anything on a number line to the left of 0. Negative numbers can be negative decimals, negative fractions, negative integers rather. And positive numbers are any rational numbers to the right of 0. So hopefully this exercise helped you clarify that. All right, then we looked at hierarchies and where would fractions be inserted. Fractions are not integers, but they are rational, so they'd be on equal level with examples of rational numbers, categories of rational numbers. Pi is another example of an irrational number. Square roots of non-perfect squares, the square root of 2, the square root of 5, the square root of 17, the square root of any number that's not a square number, the square root of 26, etc. These are examples of irrational numbers. And then where would we put negative integers? Well, integers can be positive or negative. So that would be on the same level as positive integers. But if you're negative, you can't be positive. And if you're positive, you cannot be negative. And then whole numbers, all whole numbers are positive integers. So they go between positive and primes. All primes are whole. All whole numbers are positive. So that's how we would insert those in there. All right, then I asked you some questions about these. You had to give reasons for each. Is 3 a rational number? So if you look here, 3 is an integer. It's a positive integer. It's also a prime number. All of those are under rationals, and I could just put it over 1 to prove it can be written as a fraction. Is negative 3/4 a real number? Yes, it is a negative fraction. So it's definitely a rational number, and all rationals are real. This number has a pattern. I'm just writing the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this pattern goes on infinitely, but because it continues and never repeats, I cannot ever figure out the denominator to write it as a fraction. So it is not a rational number. It's an irrational number. So it belongs over here, but it is real. And is 2/3 an integer? No, 2/3 is rational, but it's not an integer. It's not like one of those whole pieces of all of the whole numbers and their opposites, because it's a part of a number. So it's rational and would go under fractions, which could be put here. All right, and then we did this exercise where you had to figure out what categories each of the numbers belong to. So we went through this in class, and if I can scoot this down here, let me see if I can. Yeah, so you can just again look at your sheet. I'm not going to read all these to you because you've got it on your paper, but this helps you see the general classification of real numbers. All of these were real. Many of them were rational. Many of them were integers. Many of them were positive. So then we went from there to building a hierarchy in your group with slips of paper and toothpicks, and this was the answer to the hierarchy. So we had the set of real numbers. You're either rational or irrational. There was one example of an irrational number on your slips of paper. That was pi. And then under rational numbers, we have the category of fractions and the category of integers. And under integers, they can be positive or negative. So we have two categories, and all whole numbers are positive integers, and all prime numbers are whole numbers. So the hierarchy goes from the vague, or the very broad rather, to the very specific. And then you have some homework to practice. Remember, you have a quiz next class. Bring your laptop. You're going to work on your project. So anything you've gotten started with in your project should be saved in Dropbox in your math project section. So have that here ready to go.